Good afternoon, everyone. And today's our webinar topic is about smart city engineering digital tools for design and construction. My name is Kushi Pendhari, and I am presenting this webinar for smart civil engineering. Means why civil engineering is needs to be some smart because of some AI tools or kind of new automations like that. Okay. So in that, what we have to see? First of all, we have to see about what is the agenda of our webinar, means what's the point we have to be discussed in that webinar. So in that, first of all, we have to be discussed about what is introduction to smart city engineering, civil engineering. Means what we know all about the civil engineering, what are the parameters of civil engineering, what are the parts or what are the things are including in the civil engineering. But we, in actual, we don't know about what is the smart civil engineering. So it is not basically such a vast thing or any kind of different. It is just about something smart, just because of AI automations or any kind of new technologies. We have to be involved in civil engineering field. So this is what we have to be seen. After that, we have to see about what is the importance of digital transformation. Means in today's era, we are actually doing or using something old methods or any kind of old things that we have uses. But we all know about that there are different kind of new things are coming in the markets, as well as there are different types of challenges are facing by today's generation, like for the architectures, for the civil engineer, for the interior designer, any kind of person who is working in the civil engineering background, for designing 3D visualization or estimation. That kind of things are now they are to be challenges. So why it would be important to using transformation? Digital transformation is just we have to be get transform ourselves from olden technologies or olden methods to new technologies. So this is why this is important. Like what are the benefits of it? We have to be seen in that. Next one is about overview of key tools, means which type of key tools we have to be used in that, and what are the uses of them, why they are important, or which key tools we have to be used for our digitalizations. That we have to be seeing. After that, in that, what kind of tools included, just like a AutoCAD for civil in a 3D, or Revit or InfraWorks, or for structural works we have used STAAD.Pro or ETABS, or for GIS is a one kind of thing, like suppose we all know about ArcGIS or geoinformation data for military or any kind of people. They are needing geographical data that we have to be get from that, like survey or any kind of that, or MATLAB, Python, that kind of new technologies we have to be used in our civil engineering fields. And by that background, we have to be used about how our technologies is going to be at a higher level, or how we can do this as a smart city or any kind of like that. Okay, smart civil engineering. So next one is about the future of engineering with the automation and AI. Means what is the future of engineering? In data science or in computer science, they are using AI and automation, but in civil engineering, we are not using that. So how we can applicable to this? Just like we are using a AutoCAD, AI AutoCAD, in that we can paste the codes and then we can get the drawings automatically. So just like that, what is the future of engineering with the automations and AI? And last one, we have to be a question and answer session, and after that we conclude the session. So this is what we have to be seen in that. So our first topic or our first important field is about introduction to smart civil engineering. Means, what are the introductory parts? Smart civil engineering represents the transformation of traditional practices, engineering practices, to our integration of cutting edge digital technology. Means in short, this is what there are a number of traditional methods or traditional engineering practices. So from that we can integrate ourselves to new cutting edge or digital technologies. It also focuses on creating smarter and more efficient sustainable infrastructure. Means what it will be focuses on using smarter technologies more efficient, as well as a sustainable infrastructure. As we all know, sustainability is also an important thing for today's era, because we are using different kinds of building material, we are using different technologies, and by that the pollutions and all that issues arises in our modern era. So this is what one of the most important things, like a sustainable infrastructure we have to be used. After that, automation or intelligent system across all the phases, means not in just a project designing or planning, we have to be integrate that intelligent system to all over the phases, just like from planning, designing, construction, operation, and at the end of the maintenance. We have to be integrate that all the smart civil engineering to from planning stage to maintenance stage. So in that, what kind of technologies we are using? First of all, it is a BIM, is building information modeling. As we all know about what is building information modeling, why it is used. After that, GIS. GIS means what? Geographical information system. After that, AI. That all we are know about it. AI is a artificial intelligence which was in everywhere in our social media or in our daily life. We are using AI. So why not we are using that AI to our civil engineering field and make it more integrated, more automation. So after that, IoT means Internet of Things. After that, automation tools means different kind of automation tools, or drones, digital twins, advanced simulation software that we can use in a civil engineering needs. So in short, we have seen about why it is important, because it gives our accuracy, efficiency, that kind of things it will be gives us to. So in that, it integrates BIM. BIM is a most important thing, that we are creating a detailed 3D, 4D, 5D digital project models, which are combining design, cost, scheduling information in a single environment. Like as we know, we are planning for our drawing as a 2D drawing, then we can make a 3D drawing in a Revit or in a SketchUp, 3ds Max, that kind of software we can use. After that, 4D, 5D simulations means what? We can clash detect of our project in Navis work, then we can collaborate it, work sharing there is option, then we can design it, we can find out the cost of it, we can find out the schedules in just a one click. That kind of information we are getting from BIM. After that, GIS means what? Mapping and spatial planning. Means it will be doing a mapping, spatial planning, or terrain analysis. Terrain means what? Our ground analysis, or how the contours are work, how our buildings are going to be structured on it, or environmental impact assessment studies are done. AI and machine learning is what? It predictive modeling, risk assessment, optimization, data on structural health, that we can find it by that. IoT sensors is what? A real-time data on structural health, construction progresses, traffic flow, water supply system, as well as more kind of things that are going to be done by IoT sensors. So these technology drastically enhance accuracy as well as reduce the human errors. Means as we know, we are human, and the errors are done by us. But by the technology, we can minimize that errors and make our work very efficient and very accurate. So it was by automated repetitive task. If suppose we are doing estimation by manually in Excel, then we can do some repetitive task and calculate it. And some suppose there are some mistakes or any kind of that. So by the technologies, we can calculate our estimations, we can detect our clashes, we can find our material takeoffs, as well as by MSP with PPM means project planning, we can find or track our progresses which are doing in a flow. So that are all going to be get benefited to the engineers, architects, interior designers. So smart civil engineering is also improve visualization, means it improves our visualization, it improves our communication. There are advanced tools allow engineers and the stakeholders to explore their virtual models, contact simulation for the load analysis, safety checks, and the environmental impact assessment that are going to be done by this. Means if your stakeholder or client is going to be design something, and they have some kind of imagination about our structure or any kind of thing, and they can't get that structure in a realistic model, because what we imagine we can't make by our hands, or we can't that accuracy. But by that software, we can visualize it, we can make a 3D model of it, we can estimate of cost, we can detect our clashes before the structure is going to be begin to be structured. So that kind of things are done by, we can track our project. So overall, it is a smart civil engineering supports development for the smart and sustainable infrastructure, which is a better resource utilization, which reduces our waste, which lowers our impact and environmental impact and helps in a building infrastructure that adapts future needs. Means for future there is a need of a sustainable structure or that kind of, so we can do this by that methods. And after that it is just kind of a data driven technology that enable the processes very quickly, very quality friendly, safely, productively, and a sustainability in civil engineering sectors. So that is such a kind of things that we get from a smart civil engineering. Next one is about the importance of digital transformation. Why we have to be it is important to get from traditional to go to the digital. So it is a most beneficial thing. Why it is important? Digital transformation is playing a crucial role because it's reshaping our civil engineering projects are planned, designed, scheduled, executed, and maintained. By integrating modern digital tools, we can intelligent technology, the entire workflow becomes faster, more accurate, and more efficient. It will be improve your accuracy, your speed, efficiency, and civil engineering workflows. Like how it will be digital technologies like CAD, BIM software, automated surveying tools, just like a drone or the simulation system, drastically reduce the manual efforts. Means by manual we are doing so kind of efforts, but our results are not that much amount of accurate. So by that we can minimize our human errors and make a more beneficial work or more informative work. Design can be updated instantly. Complex calculations can be automated very efficiently. Field data just kind like lidar, drones, GPS system make our project faster and higher accuracy. Next one is about enhanced collaboration through the cloud-based or real-time tools. Means how BIM gives us BIM 360 collaboration tools like online project management system will brings architects, engineer, contractors, and clients into a single digital platform. Like as we know, BIM 360 is one of the most best collaborative document in which different kinds of structural engineers, architects, interior designer, contractors are getting in a single platform and they can work on it. So team members can edit a model simultaneously. That updates are visible in a real time. Communication is going to be a faster mode. So that kind of things. Next one is about it enables the data driven decision making using analytics and AI. This digital information allows engineers to use the data analytics, machine learning, and AI for the smarter, more informed decisions. Like it will be predicted structural failures or the maintenance needs. It will be analyze the traffic or environmental data for better planning. It will be optimizing material use and construction needs. And then about reduce project cost, delays, and the human errors. By automating tasks, we can detect the clashes early. We can providing accurate project simultaneously. We can use digital tools significantly and reduce the cost of our project. As well as BIM helps to identify the design conflicts before the structure. As we know, by Navis work, we can detect the clashes. IoT sensors provides real-time monitoring. We can get the real-time monitoring. AI-based forecasting helps to avoid the delays and resource wastage. Last one is about the support smart, sustainable, and future-ready infrastructure development. Means it will be help for our eco-friendly, energy-efficient, and technological advanced infrastructure. Like how green building, there is a one concept like a green building, which design simulation optimizes energy performance, smarter sensors monitor structural health and environmental conditions. Digital twins helps manage infrastructure throughout its life cycle. This promotes long-term sustainability, improves public safety, and ensures infrastructures. So that are the main importance of why we need to be get transformed from our traditional to digital. So our target audience is mainly about the civil engineer students, means students who want to understand modern digital tools, emerging technologies, and future trends in the infrastructure development. After that, professional and planners, mean they are working on engineers, site engineers, urban planners who are aimed to improve the project efficiency and accuracy. After that, architects or the consultants, designers and consultants looking for integrated BIM, visualization, simulations. After that, BIM and GIS learners, means who are using BIM or GIS learners, are related to the digital tools that want to enhance their technical skills and update the smart engineering practices. Our main focus areas is about BIM and GIS integration, means it's combining building information modeling with the geographical information system to create a more accurate aware context aware project model, and integration in helps in the site analysis, utility management, land use planning. After that, AI assisted design means the artificial intelligence to accumulate repetitive tasks, improve design accuracy, predict risk, and optimize the structure. After that, digital twins, developing real-time digital replicas of physical infrastructure for monitoring, simulation, and performance analysis. Next one is about cloud-based collaboration, means enabling teams to work together using online platform that supports real-time model, updates, remote access, and seamless communication. And after that, sustainable planning means who are using digital tools to design an eco-friendly, energy efficient, and realistic infrastructure for the simulation software that are data analytics and help to optimize the material use. Next one is about the learning outcomes, means what the learning are going to be get from that webinar is about participate means at the end of that session participant will what will understand about digital workflows for the smart designs, like how modern digital tools like BIM, GIS, AI, and the cloud platforms are streamlined design processes, reduce manual efforts, and improves the project accuracy. After that, how tools improve the efficiency, the way automation, data analytics, and integrated software environments that speed up the task. Simulation data driven planning, how simulations such as load analysis, terrain modeling, traffic flow predictions are support better design and decision and risk evaluation. Trends in civil engineering at 2025, like key upcoming technologies and the practices, including digital twins, AI assisted design, smart construction, sustainable infrastructure. That are the strategies we have to be used in that. So that are the points we have to be discussed, and then we have to be the main part of our webinar is about what are the tools by which we can use a smart civil engineering technologies. So in that, first one is about AutoCAD Civil 3D. So AutoCAD Civil 3D is an advanced civil engineering design software used for the infrastructure project for projects such as a highway, railway, land development, drainage system, site grading. It provides intelligent dynamic modeling tools that helps engineers to design accurately and more automations and manage large survey database efficiently. So in that, we have to be first seen about the surface modeling. Civil 3D allows engineers to create a highly accurate 3D terrain surface, which using the survey points, contours, break lines, cloud points, and the DEM data. So the features included TIN, means triangulated irregular networks, contour generation, cut or fill analysis, surface editing tools like a realistic terrain representations. Next one is about corridor designs for the highways. Corridor in Civil 3D dynamic is used for designing roads, highways, rail alignment, and the pipelines. Means what? Integration of alignment, profile, and assembly. Means we are making a highway or railways, pipelines. So we have to be make one integration alignment for that. Means alignment means basically a route for it, or 3D roadway geometry, dynamic updates. If the roads are not good in a direction or in a plane, or if there is a wrong slope, then the rate of accidents or any kind of things are happening. So it is a main important thing. So we have to be do using AutoCAD 3D Civil. After that, DEM or point clouds and the survey data handling. DEM is for digital elevation models for the terrain representations, point clouds for the LiDAR and the drone surveys, total station or GPS service points, automated features, extraction tools. And last one is about the earthwork and the grading automation. Civil 3D greatly simplifies earthwork planning, which is automated cut or fill calculations, or there is a grading tools like the slope, ponds, platforms, road edges, drainage channels, volume reports for the excavation and the embankment, optimize the material balancing to reduce the project cost. So this is what we can done by the AutoCAD Civil 3D. Next one is about the Revit or the InfraWorks. So Revit is a powerful building information modeling tool which are widely used for the architecture, structure, MEP design. Beyond building design, it also supports the urban planning, city scale visualization, and the collaborative project workflows. So first is about the BIM and the urban planning. Revit creates an intelligent 3D model where the components like wall, beams, door, HVAC, electrical contains embedded data, material, dimension, quantities as well as the performance details, which has an accurate design representation, automated update, just like we can change in a single view and it will be updated to all the view, and we can integrate the architecture, structure and MEP modeling. Next one is about BIM based design and the documentation. Revit generates plans, section, elevation, schedules, BOQs directly from the 3D model. So there are a lot of advantages like faster documentation, reduced drafting errors, real-time updates between the drawings, and the automatic quality and quantity of the work. Next one is about city scale model and visualization. Revit combines tools like InfraWorks, InSCAP, or the Twinmotion, allows large-scale urban planning modeling, city block layouts, urban massing studies, building road terrain integration, realistic 3D city visualization are done by this. And next one is about the traffic simulation and planning. So what is that? Although the Revit has been alone does not perform traffic simulation, it connects with the InfraWorks like traffic flow simulation as well as with the Navis work. So they will be give a vehicle movement, road network performance, parking layouts, and the pedestrian calculation. And last one is about the collaboration and clash detection. Revit offers a strong BIM collaboration feature, just like a BIM 360, or which was developed by the Autodesk, and it has a very good features like multiple team members can working on the same model, cloud-based file sharing, version control, clash detections we can done by the Navy's work to avoid design conflicts before the project begins. So that kind of features we can get from the Revit. Next one is about the STAAD.Pro or ETABS, structure analysis and design models. So as we all know about the STAAD.Pro or ETABS are most of the used for the structural designing. Means if we are doing a structural design, like structural reinforcement, load analysis, deflection of the beams or the columns or the structural members or the steel designing, we can use that. So STAAD.Pro and ETABS are two different most widely used structural engineering software that are used for the analyzing and designing buildings, bridges and the civil engineering structures. I mean, different kind of civil engineering structures are designed, analyzed and modeled by that softwares. They can help engineers to understand how a structure will behave under various loads, and as well as it will be ensure it is safe, stable or core complement. Means it will be give you a better idea about how the our structural behavior is done after the loading has been done on the structure. I mean, as we all know, there are different kinds of load are coming on our structure, just like a dead load, wind load, earthquake load, snow load, or any kind of wind load. That are the loads are coming on our structure, and by that our structure will behave according to that load. And if the loads are coming in one direction more, then there is a deflection, collapse, or some kind of damages are done in that structure. So for that we are using that softwares to analyze it before our structure is going to be begins. Means how our structure is going to be safe after taking that much amount of load. So in that first one is about the structure analysis and design. Both tools allows engineers to create a accurate 3D structural modeling using element just like a beam, column, slab, shear walls, foundation and the trusses. So in that the engineers can create a structural model with very efficiently using a beams, columns, slab and the shear walls. 3D visualization and geometry creation is done in that. Material property alignment is done in that. Auto generation of the structural components, steel, concrete and composite structures are also made in that. Next one is about the seismic and wind load analysis. It is what? The seismic or wind load is what? Seismic is one of the earthquake loads that are coming on our structure whenever the earthquake is going to be on area, and the wind load is about that depends on the wind pressure according to the location. So in STAAD.Pro analysis, we can done the powerful engines for evaluating how our structure responds to natural forces. So that two are the natural forces or the loads like a wind load. We don't know about how our nature is behaving, or we don't know the how our earthquake loads are going to be happening on the structure. So by that it will be evaluate about the forces such as earthquake and wind load, and they will be give you a response spectrum analysis, time history analysis, mean by studying it, and they will be give you a analysis of it, wind pressure zone and dynamic wind load simulation, earthquake resistant design according to the global codes. Next one is about FEM and dynamic load analysis. Both tools like finite element modeling for the precise structural behavior prediction, detailed slab and the plate analysis, stress strain and deformation analysis, dynamic load simulation like vibration, machines, load, traffic and impact loads, and accurate modeling of irregular and complex geometries. Last one is about the code-based design outcomes. Means as we are known, we are using some kind of codes for our designing. If you are working in India, you can use as a IS code, which has initials cause as an Indian standard codes. If you are working in a USA, you have to be used some international codes for ACI or ISC. Euro codes are there. For the British standards, there are BS standards. So different kinds of codes are designed for our structural modeling. As we are known, if we are going to work in a steel structure design, we are using IS 800, or if we are using for the concrete, we are using IS 456. So that kind of codes are using, and the design or code based design, so the outcome will give you efficient and seamless. So detailed design reports we get, reinforcement drawing we get, steel connection designs, member sizing and optimization, that are kind of data we get from it. So that is why we are using STAAD.Pro and ETABS. Next one is about the ArcGIS, geospatial analysis and mapping. ArcGIS or QGIS is what? It is a powerful geographical information system platforms that use to collect, analyze, visualize and manage geospatial data. It helps civil engineers to planners and urban developers to make informative decisions by combining maps, satellite data and the spatial analytics. Means what if you are using, there are some land surveyors or geographical information modeling models we have to be create. We are using ArcGIS or QGIS. So in that first, geospatial analysis and mapping, ArcGIS allows users to create highly accurate and interactive maps using a geographical data such as coordinates, survey points, satellite data and the spatial layers. The capabilities include thematic maps like population, land use, utilities. After the 2D and 3D mapping, layer-based visualizations for the roads, water lines, buildings, terrain, integration with the GPS and the survey equipments. This mapping supports planning, design, monitoring and infrastructure projects. Means most of the time they are using by the surveyors for doing 2D, 3D mapping, layer-based visualization for the roads, water lines, building terrains like that. Next one is about the land use and hydrology study. ArcGIS is widely used in the environment and planning studies. For the key applications are land use classification and zoning analysis. If we are going to be use zoning of our area, we can use this. Watershed and hydrology modeling, means in hydrology or water resource department, that software is most of the used for watershed and hydrology modeling. Floodplain mapping. Floodplain mapping means in which the flood is going to be happens many more times. For that mapping, we are using this. Soil vegetation and terrain analysis. Engineers use this data for the sustainable planning, drainage design, flood mitigations, and the resource management. Next one is about the satellite imagery analysis. ArcGIS supports high resolution satellites and the drone imagery for the powerful spatial insights. Image classifications such as urban vegetation, water bodies, change detections before after any analysis, terrain extractions like DEM or DSCM creation, monitoring construction progresses using your time series imagery. This helps in the site selection, environmental modeling, and the urban planning. And last one is about the smart city dashboard. Means what? ArcGIS dashboard is displays a real-time city data for the better decision making and the public services. Smart city we are designing for the better public services, or the to give the better things to public. So integration of IoT sensors data, real-time traffic and mobility visualization, utility network management, monitoring information performance, city management dashboard that are used. So that is why ArcGIS and QGIS are used. So next one is about the MATLAB or the Python. As we are known, they are using by the data science students or by the computer science students. So they are the two most of the widely used programming platforms by engineering for computation, simulation, automation, and advanced data analytics. They support civil, mechanical, electrical, and multidisciplinary engineering workflows throughout the powerful libraries and the toolboxes. So in that, what are the simulation data analysis? Numerical simulations is what? Both MATLAB and the Python allows engineers to perform complex mathematical and the engineering simulations. The capabilities are like solving differential equations, structural and fluid simulations, time series modeling, optimization and nonlinear analysis, heat transfer, vibration, and the dynamic system information. Means what? These tools are helps model to real world engineering problems with the mechanical accuracy. Means what? They are giving you a real time visualization or the world engineering problems. Next one is about the machine learning applications with the MATLAB and the deep learning toolbox like a Python with the libraries of the TensorFlow, PyTorch are widely used for the predictive modeling, classification, clustering, as well as the structural health monitoring. Structural health modeling is what about after some time, after some years of our structure, you have to take monitoring of our structure, just like we are going for the doctor for the health checkup regular or yearly. We also have to be do a checkup of our building, our structural model, and there are different kinds of methods are giving. Means we can understand there is something rusting of the steel or any kind of issues are happening in the model or our structure. We can analyze by the structural health modeling. After that, crack detections in the concrete using AI, traffic prediction, and the smart city analytics. Failure prediction in the infrastructure. Machine learning supports intelligent and data-driven solution in modern engineering. Next one is about the engineering automation. Both tools helps automated repetitive or the complex engineering tasks like auto-generating reports means generation of reports automatically like graphs, automated data cleaning and the processing means data cleaning and the processing of our data. Script based analysis workflow means by the script we are going to be get automatically data of our model. Automation of structural design calculation, optimization of material quantities and cost that we can done by this. And last one is about the data visualization. MATLAB and the Python provides rich visualization capabilities to convert the raw data into intelligent insights. Means we can do 2D or 3D plotting, heat maps, contour maps, surface plots, time series charts, GIS based plotting. We can use by that. Like we are know about if you are using a AI AutoCAD, we can generate a code and insert in that, paste in Notepad, and then we can insert that command to our AutoCAD. Then it will be automatically generate the layers, the building, or any kind of things that we are given in the code. So this is how we can use the AI technologies by the various kind of tools. So now we are saying about future of engineering with the automation and AI. Like what is the future of our engineering with the automation and AI? So this is what automation and artificial intelligence are transforming how engineering projects are designed, analyzed, constructed, and managed. That enables the engineers to work faster, smarter, with the greater precision by using data, intelligent algorithms, or automated tools. AI enables faster data-driven design, prediction, and optimization. First one is about artificial intelligence helps engineers move beyond the traditional manual design methods by using algorithms and learn from the large database, which give a key benefits for generative design that automatically creates a multiple design options, predictive modeling to identify the failures before they occur, optimization of material, dimension, and the structural efficiency, risk assessment using historical and real-time data. Means we can assess the risk, we can optimize the data, we can generate a data automatically. Next one is about the automation improves accuracy, reduce manual work, and the saves types. Automation tools streamline repetitive engineering tasks such as modeling, drafting, quantity takeoff, data entry, and the analysis will give you a different kind of advantages. Just like fewer human errors means human errors are minimized after the faster documentation and the analysis of work. Auto-updated drawings and the reports, simplified QA and QC process means quantity assurance and quantity survey processes are very simplified. This helps engineers to focus more on creativity and problem solving rather than manual work. Next one is about smart system that helps in the real-time monitoring, analysis, and the decision making. IoT sensors, drones, and the digital twins provides continuous data from the construction sites, and the operational infrastructure capabilities include monitoring structural health, means crack, vibration, loads, tracking construction progresses in real time, automated alerts for the safety and the performance issues, data-driven decision making, and the maintenance and the upgrades. And last one is about leads to smart and sustainable resistance infrastructure. AI and automation supports the development of infrastructure that is efficient, eco-friendly, prepared for the future challenges, which benefits includes reduced materials waste as well as the carbon footprints problems, optimized energy and resource use, resilient design against the climatic change, and better urban planning for the smarter and the transportation system. So this is why we are using AI or automation tools for the smart civil engineering, because it is important for the future of engineering. By that point, we can understand why it is important, what are the benefits of it to our today's new generation, like why we had to convert our traditional methods to our new methods. So now we are concluding our session. So in that we have to be seen digital transformation is reshaping the civil engineering industries in every phase of project development, like from planning and design to construction and maintenance. Modern tools like a BIM is building information modeling, GIS, AI simulation platforms, and the automation softwares that are significantly improving the way of engineering works. So what are the points we had used, or why we use that? So it will be improve your accuracy and precisions, means BIM ensures accurate 3D modeling, clash detections, coordinate system. GIS also improve geospatial precision for mapping, land analysis, urban planning. Structural softwares like STAAD.Pro, ETABS enhances the precious and the structure analysis by the code-based design. After that, higher accuracy and efficiency as well as the productivity. AI-driven modeling, predictive analysis, and the automatic workflow reduce manual work, as well as the tools like Civil 3D, Revit, InfraWorks accelerate the designs, documentation, and the visualization. Simulations in MATLAB or the Python optimize engineering decisions faster. Next one we are using, like it has a very better collaboration and the communications. Means BIM is the multidisciplinary teams, or the very different kind of peoples are working together. Like as we are know that one person is not going to be design a whole design. Suppose I want to design a model or a structure, and I'm an architect or an engineer. I can't design a whole structure. Like there are a lot of things, just like structural designing, electrical designing, plumbing designing, interior designing, architectural designing. So that way, that all kind of works are not going to be done by only one person, or detection of clashes, making estimation of it, quantifications, that all are the different kinds of things we have to be done in our model. So that one's not done by only one person, hence we require 2-3 people, or our team is required for working on that model. So by the BIM we can do better collaboration and the communication between different peoples with the technologies like BIM 360, in a Revit we can collaborate your work, or we can work share our work, as well as GIS and the cloud-based dashboard supports cross-team visualizations, communications, and the city planning. Cloud tools ensures better version control and the project coordination. Smarter and sustainable infrastructure, like with data-driven insights, engineer design more realistic infrastructure. As we all know, the AI supports predictive maintenance, failure forecasting, and the optimized designs. GIS also helps to assess the environmental impact, hydrology, land use, and the suitability. Smart modeling reduces resource works, supports greener construction practices. Next one is about the future ready engineering. Why we are using this? That are the main important part for the future engineering. As automation, AI, digital tools continually involves engineers, architects, interior designers, contractors to must adapt and upgrade their skills. Integration of AI, digital twins, IoT, and the simulation will shape the next generation into mega projects. Optimization, embracing digital workflows, gain competitive advantage and improves the project outcomes. When by using all the tools, we can give a better outcome to our project, we can do a better collaboration, we can get the better things. Means, as we all know, if you are going to be minimize the traditional methods and using new methods, replacing it with the new methods, new technology, we are getting more benefits. We can minimize the cost of our structure, we can reduce the wastage of our work. That kind of things are can be done by us, because as we all know that some traditional methods of civil engineering are so lengthy, they are giving a very time consuming. So by using new technologies, new software, just like AutoCAD, Civil 3D, or a Revit, or a SketchUp, Naviswork, we can detect our clashes. Suppose we are building a structure on our site, and you can get some clashes. Like suppose your beam or your duct is going to be combined, or electrical pipings or any kind of thing are going to be getting combined with each other. So there are the clashes are begins on that. So by our new technology, just like if you are using a Naviswork, you can detect our clashes before the structure is going to be constructed on a site. Like if you are doing a construction on site, and then there will be a arises of issue, you will get more confused, or you can't understand what to do right now, and the material, the efforts of the people, or the things are going to be backward of that project are going to be wasted. So to reduce that, we are using new technologies. If your engineers know what is the clash will happens, or what are the conflicts will be happen after doing that all the kind of stuff, or that all the kind of things, then we will get understand what to do next, or how to minimize it, or how to reduce it. So that are the things we can done. Or suppose your client or your stakeholders are having imagination, like I want that kind of home, or what I want that kind of structure, I want that suppose I want that kind of balcony, or that are the interior designing, but they can't visualize it, because if you are dreaming in your own mind, and you are not explaining it to the people in front of your, to the interior designer, to the engineers, then how your work will be done. So to avoid that, we have some new softwares in that you can design whatever your imagination, whatever the kind of things you are imagining, whatever the kind of things, materials you want. You can add any kind of material, you can add any kind of designs, as well as you can add any finishes, furnitures as per your requirement, and design your structure very efficiently. So your client will be more happier than earlier by this. So it is a best way to have kind of things to be done in your model, or can visualization, modeling, 4D, 5D, you can done by the different kinds of softwares. So it will be give more beneficial to our new generation, or to the new entrepreneurs, or the engineers, interior designers, stakeholders, or any kind of person who are going to be or work in the civil engineering field, or the architectural field. They will get more benefit of our smart civil engineering, using AI tools, using different kinds of new software. So so this is about the ABC trainings. If you have any issues, or if you want to learn that software very beneficially, very efficiently, this is our QR code. You can scan and get more information about our institute, or about the courses, about the softwares that you have to be learned. Or if you're not scanning it, there will be a one contact number. By that you can contact to different authorities and get more information about our institute. Thank you.